This is the key questions, my best friend quiz review. For the quiz on quiz day, which will be November the 21st and November the 22nd for A and B days, you're going to be expected to fill this chart out and do a sample problem from each section. I'm going to help you with this, just a quick review. So taking a look here on the left-hand side, let's do the original SOHCAHTOA. So we use SOHCAHTOA when we have a right triangle, and when we have a right triangle and we have an angle, and we need a missing side. We have a missing side. We use SOHCAHTOA. And under these circumstances, we use sine of theta over 1 equals, and then sine is going to be the opposite over the hypotenuse. And cosine, SOHCAHTOA. Cosine is going to be adjacent over hypotenuse. Tangent, theta over 1, is going to equal opposite over adjacent. So you should be able to define all three of those. SOHCAHTOA. SOHCAHTOA. Then you need to show that you can apply this. For example, right here, in this diagram, first we're going to label opposite, adjacent, and hypo. So from our 48, that 13 is going to be opposite. And this x is going to be our hypo. Then this side is our adjacent. So we have the opposite. We need the hypo. So we can see right now we have an OH combo, that's sine. So we pick this one up here. We're going to go sine of theta over 1 equals opposite over hypotenuse. You want to get that copied down. Now you do circle, plug, chug. So in this case, it is sine of theta is 48 degrees. I put parentheses around that over 1 equals opposite, which is 13, over our hypo, which is x. We cross multiply. I'm going to bring it up here, so I get sine 48 times x. It's going to equal 13. So I see I need to divide by sine 48 this time. And I get x equals 13 divided by the sine of 48 degrees. From here you get your calculator out. Just make sure you do this accurately. So for me, this is going to be 13 divided by 48 sine. You can see up here 13 divided by the sine of 48 equals, rounded to the tens place, I get 17.5. Now, Let's change those circumstances. Let's say you have a right triangle with two sides, and this time you need to find an angle. This time you need to find an angle. So to find an angle, you use what's called inverse SOHCAHTOA or arc SOHCAHTOA. And for inverse sine, it goes like this. Inverse sine, the opposite over the hypo, gives us angle theta equals theta. Cosine is going to be adjacent over hypo. Gives you angle theta. And tangent, inverse tangent, opposite over adjacent, gives us angle theta. So let's apply this to our two diagrams below. From this angle, I have both the opposite and the adjacent. So I have an OA combination. So for this one, I'm going to use TOA, inverse tangent. Here, I have an adjacent, that's adjacent, and a hypo. So that's an AH combo. So for this one, I'm going to use inverse cosine. So now you do your plugins. This one on the left is inverse tangent. So you write inverse tan and inverse cosine. Here, inverse tangent, opposite over adjacent, equals theta. Here, inverse cosine, adjacent over hypo, equals theta. Let me bring this close so it's easy to see. Okay, so for here, we're going to do inverse tan opposite, which is 10, over adjacent, which is 20. So you do inverse tan, 10 divided by 20 gives you theta. So in my calculator, it goes like this. 10 divided by 20 equals, then I do inverse tangent, and I round to the nearest whole degree, 27 degrees. For the one on the right, inverse cosine is going to be adjacent, which is 12 over hypo, which is 19. So in the calculator, we do 12 divided by 19, inverse cosine, and I get 51. Okay, so that's the two different variations of SOHCAHTOA. You use this when you have a right triangle and an angle, you need a side, or you have two sides and you need an angle. Now in the back, we have some particular shortcuts. Pythagorean Theorem. If you have a right triangle with two sides and you need a third side, that's when you use Pythagorean Theorem. You have two sides and you need a third side. If you have two sides and you need a third side, you use Pythagorean Theorem. The version you're familiar with is your leg squared A plus the other leg squared B equals the hypo C. So A squared plus B squared equals c squared. The version that I prefer to use is the descriptive version, which is leg squared plus the other leg squared equals the hypo squared. Using this, you use this when you have two sides and you need a third side. So for example, we see here we have a leg and we have another leg and we want the hypo. Always label your sides, leg, leg, and hypo. So we write out leg squared plus the other leg squared equals the hypo squared. So our first leg, we circle, leg, leg, we have 6 squared, plus the other leg we don't know, we'll call it x squared, equals the hypotenuse, which is 9 squared. Now you work it out, so I have 36 plus x squared equals 81. I'm going to minus 36 both sides. I'm going to end up with x squared equals that's 45. So we're going to do the square root of both sides to backtrack it. Square root of 45, that's going to be 5 times 9. And then this is 3 and 3. The 3's come out. So my final answer is 3 square root of 5. That is the length of my hypo. You use the Pythagorean theorem when you have two sides and you need a third side. Now, we even have shortcuts for the Pythagorean theorem. They're called special right triangles, and they are specifically the 45, 45, 90 and 30, 60, 90. So if you have a right triangle with a 45-degree angle, you use this shortcut. If you have a right triangle with a 30-degree or a 60-degree angle, you can use this. And we use this to find missing sides. In a 45, 45, 90-degree triangle, whatever one leg is, the other leg is automatically the same because it's an isosceles right triangle. The hypo is whatever the leg is times the square root of 2. So in visual format, the legs will be equal, and the hypo is whatever the leg is times the square root of 2. That's a 45, 45, 90 triangle. Let me give you an example. Here in this triangle, we have 45, which makes this 45. So step 1, we know immediately that these are equal, both of them. Whatever they are, they're the same. To get to the hypo, we times by root 2. So we do this. Something times root 2 gave us 6. Something times root 2 is 6. So we ask ourselves what that something would be. So you start working yourself backwards based on radicals. So first we know we need a root 2 because root 2 times root 2 is 2. Then we ask ourselves what times 2 is 6. The answer is 3. So this right here is going to be 3 root 2, and this is also going to be 3 root 2. Why? Because the legs are equal. That's a 45, 45, 90 triangle. In a 30, 60, 90 triangle, the table looks like this. You must have this memorized. Whatever the leg is. To get to the hypo, you simply times by 2. So the hypo is 2 times the short leg. That's why I use SL for the short leg. The long leg is whatever the short leg is times the square root of 3. You must have this memorized. So for here, the short leg, to get to the hypo, we times by 2. So this is 2 times the short leg is, well, whoops, wrong way, that's not the hypo. This is the hypo. So you times by 2, so our hypo is always going to be 2 times the short leg. And our long leg is always the short leg times root 3. That's your 30, 60, 90 pattern. So using that, let's backtrack and see what we have down here. First we label short leg, long leg, hypo. This is the short leg, so I'm going to call it SL. This is our hypotenuse. That would make this 12 the long leg. So we have to work with that first. We know the long leg is whatever the short leg was times root 3. So the way we look at this is we have something times root 3 gives us 12. Something times root 3 gave us 12. Now you have to work out what that something is. Well, you know you need a root 3 there, because root 3 times root 3 is 3. And ask yourself, what times 3 is 12? The answer is 4. So for our short leg, we have 4 root 3. To go this way, we're going to times by 2. So we do 2 times 4 root 3. You only multiply the outies, so it's 8 root 3. So our hypo here, in this case, is 8 root 3.